Yeah, okay, good. So, first of all, I would like to thank organizers of this conference, and I'm glad to be here. So, here we see examples of monomorphemic words versus polymorphemic words, like a child, which is monomorphemic, and childhood and childcare. Childhood is derived words, and childcare is a compound. So, according to processing models that involve parsing or decomposition of complex words, this requires additional processes, and as a result, we have slower reaction times in tasks such as lexical decision for complex words. But there is some studies that argue that actually in some cases polymorphemic words, complex words, can be processed faster than monomorphemic words. For example, when we have derived words with productive suffixes or compounds which are transparent. So, according to, for example, the race model, which is a dual root architecture model with parallel processing temporal dynamics, those words can be recognized faster than, complex words can be recognized faster than monomorphemic words. And explanation for this is probability summation or statistical facilitation, which in essence means that the reaction time in a given trial reflects the processing time of the root that happens to be the fastest on that trial. So, however, the crucial challenges for the race model are strings that are polymorphemic strings that are formally fusional, right? Like in words food, feed. So, does this model predict faster activation of the word food if we see word food, or does not? And I guess that the race model is not the best model for prediction this kind of words, because we cannot expect decomposition when we see words like food, because it's morphologically simple words. So if we compare to words table, which just doesn't have allomorphs, like allomorph table, and words food with two allomorphs, then should we expect some facilitation of word allomorphs, or maybe there is some inhibitory effect because of variation of the forms, but no variation of meanings? So, and I guess we can expect some activation of this food and feed allomorphs if we adopt this lemma terminology of Lefeld at the lemma level, abstract level of word decomposition. And do we have some evidence of benefits of such decomposition of possible allomorphs? So we do have there is studies that argue that the greater involvement of irregular words with other parts of grammar facilitates the memory processes associated with irregular forms, and studies that argue that semantic factors such as morphological family can facilitate processing, and complexity of the inflectional paradigms is also one of the facilitating factors. And studies that argue that in our mental lexicon, words with more complex and informationally rich paradigms have more links to other words. So we have evidence that actually if we have a variation in form, maybe it is maybe it can have facilitating effects instead of inhibiting effects. So, but then we should ask, do stem allomorphs have lexical status? And we have some evidence from studies of Finnish that stem allomorphs actually can have some lexical status at the lemma level, so abstract level of decomposition. And there is some studies of Spanish morphology as well as some studies of Arabic language non-concatenative morphology, which that studies are good that we should expect some lexical status of stem allomorphs. Although, of course, stem allomorphs are not real words, they are like pseudo-words, but still, they are not pseudo-words in this sense that they may have lexical status in comparison with pseudo-words. So, our first experiment was made with nominative singular words in Finnish language, and here you can see two paradigms. So here you can see two words, word vesi, which means water, and the word lasi, which means glass. And if you see at the paradigms of words vesi and lasi, I guess you can see which one is more complex, which paradigm is unproductive. What is your guess? Do you see? So this is stable. So we can guess that it is productive one. It is less complex. This is unproductive. This is more complex. That's right, because we have many allomorphs already in singular. And here there is no allomorphs actually in singular at all. So this is productive one, this is unproductive. This is complex, this is not complex, okay? Then what if we what if subjects can see on the computer screen these words in nominative singular, and the task is to divide between words and pseudo-words, so like a simple lexical decision paradigm. And should we expect activation of allomorphs? So a subject don't see allomorphs, but our hypothesis is that we still can expect activation of those allomorphs, that even if you don't see allomorphs. So, our other hypothesis is that we should expect some facilitation of those allomorphs at the lemma level. So, and the results are, it was a single lexical decision task with ERP, so EEG measuring, and the results are, I'm sorry, yeah. Start with this one. So here you can see on this figure, you can see grand average global field power, curves for words with lower, a thick line, and greater thin line stem allomorphy. And as you can see, our brains are allocated more power to words with more power to words with greater stem allomorphy, so to unproductive words. And in this graph, you can see grand average potentials at the vertex for words with lower and greater stem allomorphy with the right mastoid reference. So here you can see two things. First of all, we can see shorter latencies for in late positive component, in the late positive component for words with greater stem allomorphs. So behaviorally, subjects recognize words with greater stem allomorphy faster than words with lower stem allomorphy. And the other thing that you can see, reduced N400 component for words with greater stem allomorphy, which is predicted by many other studies that argue that if you see some facilitation in lexical decision, then you can find reduced N400 for those components. Okay, so here you can see topographies, ERP topographies for words with lower stem allomorphy and words with greater stem allomorphy here. And this is the difference. So it shows potential distributions of the lower minus greater difference and correspondence p-value. You can see here. Okay, but our second experiment is about what if we add some new paradigm, which is in terms of number of stem allomorphs, it's the same as productive Lassie-Glass paradigm. We already know. But in terms of productivity, it is completely unproductive. So it is the same as Vesey paradigm. So this, we can call this paradigm as semi-productive, but actually it's not semi-productive, it's unproductive at all. But there is no more stem allomorphs, so exactly the same number of stem allomorphs like in productive type. But unproductivity is, we can explain unproductivity of this type because of morphophonological variations in the paradigm. Oh, I'm sorry. So what happens now? We, in our second experiment, which was not factorial design experiment this time, it was data analysis were made with kind of regression model, and we have a dependent variable reaction time, and as explanatory variables we use different variables like for example collected from 16 participants that didn't take part in the experiment, like a subjective frequency, level of concreteness, picturability, familiarity as a proper name, because some nouns in Finnish language tend to be a proper name as well, and a regular noun. So here we have other explanatory variables. So this kind of variables, and we can see that if we put all these variables in the model and we try to predict reaction times, then this type, semi-productive, unproductive as well, and productive type, they are showing slower reaction times, significantly slower reaction times in comparison with unproductive type, Vesey, water, and there is some other variables that are showing significant level, so like a subjective frequency, picturability, neighborhood density, and interactions between type and subjective frequency. So as a result, if we go back to the, if we go back to this slide, you can see that results are supporting hypothesis that there must be a number of stem allomorphs if you want to see some facilitation effect in reaction times. So it's not enough to have morphophonological changes and no allomorphs. So it's not enough to be unproductive to show some facilitation effects. There has to be a number of stem allomorphs. So, and again, results, we can explain results with statistical facilitation. I repeat that reaction time in a given trial reflects the processing time of the route that happens to be the fastest one of the trial. So we have many routes here, and we don't have many routes here, just one. Although there is some morphophonological variation here, but no allomorphs. So our further study, oh, I'm sorry, yeah. Is we are planning to prepare exactly the same lexical decision experiment with 20 healthy elderly controls and 20 patients with Alzheimer's disease, because Minna Lehtonen told us early on that there is activation of morphophonology or morphology and morphosyntax in the frontal lobe, in the frontotemporal network, but we know that patients with Alzheimer's disease, they are showing some deterioration in language, okay, but because of lesions, or not lesions, because of beta amyloid plaques and tau protein in temporal lobe, first in mild stage of the disease, but in severe there is also in the frontal lobes deterioration of brain tissue. So it's interesting to see, are there any, so do patients with Alzheimer's disease do they show exactly the same activation of stem allomorphs, and if they do, then is it facilitating or inhibiting, facilitation or inhibitory effects can be seen. So, and if we don't see any facilitation of activation of stem allomorphs, then we can argue of deterioration of morphology, which is not the obvious finding, because many studies with Alzheimer's report that actually their morphology is even in severe stage of the disease is not impaired as much as semantics or lexicon. So, thank you for your attention.
Thanks for the talk. A very small technical question. How did you induce N400 in your study?
How do we induce N400? So,
because to get N400, you always need some special manipulations, like, you know, plays with contacts, presenting something before the presentation of the board.
So there was, the study was about lexical decision between words with greater stem allomorphy versus words with lower stem allomorphy. So subjects were pushing button for words versus pseudo words, and it is just a result that we had the N400 for and reduced N400 for words with greater stem allomorphy versus lower stem allomorphy. But I'm not sure about did I get your question appropriately?
I have a clarification question. When you say that the critical items had complex stem allomorphy, did you actually present a form with allomorphy, or was it a surface stem that looked like any other stem, but the paradigm has
Yeah.
complexity.
Yeah, the second one. So
Okay,
subjects,
that's important. Yeah. So, in other words, those stems that have rich allomorphy are kind of more saliently represented in the brain, if you want.
Yeah, yeah,
That kind of thing.
yeah. Right.
And just one comment, a side comment, when you said that morphologically complex words are sometimes processed faster than monomorphemic words, and the example was childhood. Just to make sure, childhood is faster than a monomorphemic word that's equal in length. A long word that is difficult to parse. You know, when you have morphological structure, it's easier to parse it. So childhood is certainly faster than a very long word, but it's not faster than child.
This childhood is not necessarily an example from the studies I mentioned.
No, of course. Just as a matter of principle, when you match a long monomorphemic word to a polymorphemic word,
Yes.
it's easier to process a polymorphemic word because it's easier chunked.
Yeah, yeah, and because of the same activation of so subjects are trying to get this target by processing whole words and the components, constituents of words simultaneously.
And just to make sure,